Welcome to this session of rapid prototyping. In previous session, we were discussing HTML file format and different way that the object can be represented in HTML file format. Basically, it will be represented in the form of triangles. In this session, we will discuss different file formats that are there in rapid manufacturing domain in additive manufacturing domain. So, the file formats for additive manufacturing, there are actually many file formats: the object file format, STL file format, VRML file format, PLY, FBM, X3G, 3MF, AMF, that is additive manufacturing format, G code. All these are there used by different machines, but we are not discussing all this. What we are discussing is this all file formats. We will discuss IGES, STEP, STL. Already we have discussed most of it. We'll look on SCL, CLI, RPI, LEAF, HPGL, and CT. All these file format, we'll just see the brief about different file formats, and we'll discuss what each of these means and how the data will be stored in each of these file format, along with some overview of advantages and disadvantages of each file format. By far, the STL is a de facto in additive manufacturing domain. So most of the time we will be using STL file format in the machines, but IGES and steps are used to convert or transfer some other files into STL file also, and other file formats will have their specific applications also. Let us start with IGES file format. Now, IGES is Initial Graphic Exchange Specification. This is a standard that was developed by all the organizations initially when the CAD was a new concept, where each CAD system has their own file format, and everyone was using some different file format. So they decided to come up with a common file format, and they came up with this Initial Graphics Exchange Specification. Now that is the standard used for graphic information between commercial CAD software. What are the advantages of this IGES? It is very precise representation of CAD model. So IGES can accurately represent any CAD model. Now there are some also disadvantage for IGES when we talk about rapid prototyping or additive manufacturing technique. The most significant one, the most prominent one, is the redundant information, because when we are making a prototype out of any STL or any file, then all the information we need is just geometry or specifically 2D data. But this IGES format will have many information which is not needed for rapid prototyping. It might be helpful for other CAD applications. For example, data about the color, data about the geometric topology, data about the mass, data about the material. All this information will be there in IGES. But when we are doing rapid prototyping, those information are not needed to us, so it will be a redundant information, and it will be an extra burden on the software when we are processing IGES file. So that is a disadvantage of IGES file. Also, the slicing of IGES file are more complex, because we need more complex algorithm than the STL file. STL file only represents triangles, so slicing of STL file is comparatively very easy. Algorithms for slicing the STL file are comparatively much more straightforward. And another problem is that support structure needed in RP system cannot be directly generated from IGES file. So you need to have a separate model of support structure which you need to store in IGES format to create the sizing. So these are different disadvantages, and this is why IGES is not preferred over STL. Now another file format is step file format. Now STEP stands for Standard for the Exchange of Product Data. So this step was developed by ISO 10303. It is an international standard which comes under ISO 10303, and it is standard for exchange of product model data, which stores many informations about product model, and it is used for different representation between product data of different engineering application. So if you want to change your 3D CAD system, and you want to change your model into in between 3D CAD system. So you want to change, you want to move from Creo to ANSYS, say. So you want to import your model into ANSYS from the Creo. Then you can save your model in the step file in Creo, and the step file can be opened in the ANSYS. It is basically a standard for computer interpretable representation of engineering purpose model data. So all the engineering purpose applications will use step file. But the problem is that there is no step application protocol that covers layered manufacturing. So step has many application protocols which are used for different applications such as FEA, computer aided manufacturing, CFD, etc. But there is no step application protocol that is used by layer manufacturing. So one has to develop this application protocol to use step file directly in additive manufacturing. Now the STL file, that is stereolithography file or standard triangle language or standard tessellation language that we already have discussed, is de facto of all the additive manufacturing technology. STL file is most widely used in additive manufacturing domain. It is representation of the surface by triangles. This already we have discussed in the previous session, and this is widely used for various additive manufacturing technology. Now the problem with STL file is that it stores only surface geometry. It does not store any additional information. So for example, if you want to make a color polyjet printing, you are using a 3D printer, colored 3D printer, and you want to print different colors triangle. So STL file will convert your model data into different triangle. Now you want some triangle to be of different color, another triangles to be of different color. Then STL file does not provide any data of this color information. You need to separately use some other techniques, some other software to add that color data. So this is a limitation of STL file, that it stores only surface geometry. But this is also an advantage because it makes STL file very compact when compared to other formats and very easy to use when compared to other formats. Now stereolithographic contour. This is extension of STL file. Now remember, STL file stores the information in the form of triangle only. But SLC is a two-dimensional slices that are directly taken from CAD model. So it is not tessellated STL model. So it is not triangulated model, but it is the actual arcs in the 2D model. So STL file cannot represent a circle very accurately because it cannot represent arc. But SLC represents arc very accurately because it is not converting it into triangle. It directly stores it as a arc. And a SL file is a 2.5D model. So this is not 21 by 2D model, but this is 2.5D contour representation of a CAD model. So it will be more accurate than STL file because it can store other than triangles, it can store arcs also or other representation of surface also, say B-spline and all the other curves also. Now we are talking about this other format, that is CLI format. Now CLI is common layer interface format, and it is a simpler format of HPGL. We will see what HPGL is, but common layer interface format will store data in polylines only instead of lines and arcs. So STL file stores data in triangles only, but you cannot use squares or hexagons, etc. But CLI can store information in square, even different polygons like hexagons, etc. And it does not have to be a regular polymer. Oh, sorry, regular polygon. So you can have different lines making of different dimensions, making different shapes, but we can only represent the object via lines only. So there will be increase in accuracy than STL, but it will be not as accurate as actual CAD model. And in CLI also the slicing step can be avoided in some application if your object is simple. If it is complex, then you need to do slicing. And the problem is that the error in the layer information is much easier to be correct than in the 3D information. So each layer will have a different information, and if there is an error which will be there in 3D information also, which will be there in 2D information also, we can easily correct errors in 2D information. So this is very helpful in common layer interface, where we can automate the recovery procedures for repair of these errors, and editing is also very easy. Now the only problem with CLI is that it can only produce polygon, and the outline of the slice can only be represented by polygons. It cannot represent arcs, so there will be some loss of accuracies. Now this RPI, that is Rapid Prototyping Interface, is an extension of STL file format. So RPI can be derived from the STL file format data. Now what RPI is? RPI contains topological information also, instead of just triangulars. So what we can do is that in STL file we know that there will be redundancy due to the same point, same vertex represented again and again. So in RPI, instead of mentioning same vertices, all the 3 dimension of vertices, we can give name to each vertices, and we can say that each triangle will have these vertices. So for example, let me just show you. So for example, if we have this type of shape, so this is one vertex, this is another vertex, and this is the third vertex. So in STL file, I need to specify all the 3 point of this vertex in XYZ, all the 3 point of this vertex XYZ, and all the 3 point of this vertex XYZ to represent this one triangle. That is okay, there is no issue. But to represent this triangle, I again need to mention all these 3 vertices and all these 3 vertices and this vertices extra. So I am storing 6 data extra, 3 here, XYZ here, and XYZ here. So instead of adding these 6 data, what I can do, I can give numbers here 1, 2, 3, 4, and the vertices information, the XYZ coordinate will be stored in this number. And what I will say that first triangle will have 1, 2, and 4 vertices, and second triangle will have vertices 4, 2, and 1. So instead of multiplying all these 3 XYZ coordinates, I am just adding one number of vertices extra only. So this is advantage in RPI file format. If this seems somewhat difficult to understand, then don't worry. This is advanced level understanding of how the RPI file format works, but this is very straightforward to understand why RPI will be a smaller file format, because it have small number of information, it has small number of repetitions than STL file format. So that's why we are moving towards RPI, rapid prototyping interfacing. Now this is why the redundancy is removed and size of file is compacted. So basically the file size will be less. And interpreter, the problem with RPI is that in HTL the interpreter is very straightforward, but the interpreter which will be used in RPI format is more complex than the HTL format. So interpreter is basically the software which will read what RPI format is saying, or what any file format is basically saying. So to read out the RPI file format, you need some complex algorithm than HTL file format. Because HTL is straightforward, in RPI we are having some complexities. Then there is this leaf file format, which is layer exchange ASCII format. Now layer exchange ASCII format is a 2D representation of the surface, and it will have 2D primitives. Primitive means small objects like triangles, squares, circles, polygons, uh, lines, polylines, etc. So these leaf formats will have these 2D primitives which are predefined, and they will be placed at different places to make entire surface. And at the current moment the primitives that are being used are polylines only, but others are being added. Leaf format is comparatively easy to implement and use, and it is not ambiguous. Anyone can understand it. Also the leaf format is human readable, so anyone can see at leaf format and understand what the representation is. But the problem is that some new interpreters will be needed to read the leaf file to connecting rapid prototyping system. Now all the rapid prototyping system have interpreters which can use or understand HTML file format, but for leaf file format we need to add another interpreter which can understand it. And the leaf file format is also more complex than HTML file formats. Then there is HPGL file format. We talked about HPGL in CLI. What HPGL file format is? Remember, CLI file format only uses is polylines, only lines. But this Hewlett Packard graphics language, this is a name. Hewlett is a name of a person. Packard is also name of person, and these guys develop this graphic language which is known as HPGL. HP, Hewlett Packard is basically the company HP also. So these are the names of the founder. Now HPGL are two-dimensional data type format. So we will have 2D objects in HPGL, and lot of commercial CAD system have the interface to output HPGL format. Basically the 3D printers made by HP. The 3D printing technology, the 3D printings I am talking about jet printers. So this jet printers which uses binders made by HP and other technology developed by HP supports HPGL format, and it will give just 2D geometry data of the file to the format. So this HPGL does not need to be sliced because we are already giving 2D data. But how we will get this HPGL file? So from the 3D model we will slice the 3D model, and from that slicing we will get HPGL. Now HPGL uses arcs and curves also. So HPGL can represent exact shape of 2D model. So it will be more accurate than other polyline formats because it represents arcs also, curves also. So this will be more accurate. And the problem is that support structure required must be generated in the CAD system itself and cannot be generated in the slicing system or in the STL system. So we need to generate support in the CAD system and then we need to slice it. This is the main disadvantage of HPGL file format. Also, this 2D, each HPGL file will have only 2D data. So you need to store multiple HPGL file, and you need to give them some sequencing, so that each layer will have that logical sequence, and each layer will be produce this number by number each HPGL file one at a time, because each HPGL file is 2D data, so you need to stack all the HPGL to produce an entire 3D model. Now this CT or computerized tomography file format is a scan data, and it is very much used in medical imaging only, because the CT technology is used in medical imaging only, and this is not any standardized data, so it will not have any particular specified predefined file format. All the manufacturer will have their proprietary software, and all the manufacturer will have their patented software and their patented formats. So every machine, every CT scan machine will have different way of storing the CT data. Now the CT data generates a grid of three-dimensional points, and each these three-dimensional points will have varying shade of gray. So the darker the shade, the gray, the denser the material, that will be the norm. So it indicates density of the body at a particular point. So CT data can be used to generate the data about density at different level of a component, and this is very useful when we are doing 3D printing of parts, and we want different density in different area. For example, if you are making a SLA, then entire model will have same density. If you are producing something with FDM, then entire model will have same density. But if you want a different part of the different area of the product, different density, then STL file format cannot store any information about density. All the previous file format that we have seen cannot store any information about density, but this CT can store this information. But again, the CT, computerized tomography file format, is very application specific. So these are different file formats that are used in the field of additive manufacturing. This will be all for this lecture. Happy learning.